Okay, in a previous lecture, we explored what happened when you added two vectors that formed a right triangle. So we might have this vector, and then the resultant vector made it form a right triangle. But what happens when you have adding head to tail? Notice head to tail. That doesn't form a right triangle, does it? And then our resultant goes from where we started to where we ended, and we end up with something like that. And this shape right here is not a right triangle, but that shape right there is. So what we're going to do is we're going to take the parts of these, but we're going to even do it even more complicated. Dun, 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 dun. Okay, so let's have 10 meters straight up. Let's have 10 meters at, okay, we always measure our angles from the horizontal, 30 degrees. And then let's go down this way. We're going to measure that from the horizontal, so this is going to be trickier to see. So that angle right there is 60 degrees. Okay, so see, here's the horizontal, and we're going to measure from there. We don't want to go this way because that's greater than 90 degrees, so we don't want to do that one. Okay, so our resultant goes from where we started to where we ended. Let's say that this one is 15 meters. Okay, so what we're going to do is we're going to break these up into the horizontal and vertical components. So we're going to use our SOHCAHTOA. And remember, the x component is the vector times the cosine of the angle. And the y component is the vector times the sine of the angle. Make sure your calculator's in degree mode. So we're going to use degree mode in physics. Okay. Got the setup? Okay, our drawing should match our final answer. So our final answer should have a fairly small number, and then it should be, an angle maybe less than 45 degrees, because 45 degrees splits that in half. All right, let's shrink all this down so give us some room to work. Okay, remember the Cartesian plane? Okay, here's your x, and here's your y, and in the first quadrant, your x is positive and your y is positive. In the second quadrant over here, your x is negative and your y is still positive because it's up. In the third quadrant, your x is negative and your y is negative. Everybody's negative there. And in the fourth quadrant, okay, you're in the positive x and you're down, so you're in the negative y. Okay, you can always use this, but you do not have to. You have the power to say which direction is the positive direction and which direction is the negative direction. Because remember, positive, negative in physics, important idea, positive, negative physics just tells us direction. Okay, so if you defined left as the positive direction, you would just make everything that is on this side, okay, you would make that a positive x, and this would be a negative x. You have the power. You do not have to be following this. You can change it. It's a very important thing. Some physics teachers don't think you can handle that. Okay, so we want to separate our x's from our y's. So here's our x's, or our horizontal, and here's our y's, or our vertical. Okay. Okay, let's take our first vector here. 10 meters straight up. How much of that's going sideways? Okay, so we don't have to use sine and cosine when it's straight up. None of it's going in the horizontal direction, and it is all going straight up. So the x component is 0, the y component is 10. The second one here, we're going to break it up into its horizontal, because it's at an angle. So whenever there's an angle involved, that's when you're going to use sine and cosine. So we're going to go 10 cosine 30 and 10 sine 30. All right, let's see if we need to make these positive or negative. Is this guy here going left or right? You see he's going towards the right, and right is the positive x direction. So we're going to go ahead and we're going to deliberately make this positive, even though it's understood. That just says, hey, we assigned our signs. And then, is this guy going up or is he going down? See the arrows pointing in the up direction? So up, positive y direction. So we're going to deliberately make this positive. All right, then our last vector. Okay, that one's 15 at 60 degrees. So we're going to go 15 cos 60, 15 sine 60. Okay, and let's do our positives and negatives. So, is it going left or right? It's going to the left, isn't it? Is it going up or down? It is going down. So we're going to make that negative too. Okay. These do not both have to be positive, and these do not have to be negative. If I had a vector that was going this way, okay, it's going to the left, so it has a negative x, and it's going up, so it has a positive y. So base your positives and negatives on which direction your arrow is pointing. All right, all we have to do now is add these together, and that gives us, okay, so that gives us 1.16 on the x direction and 2.01 on the y direction, and so both of those came out positive. And that's what our drawing showed our resultant going up and to the right, so that makes sense. So what we have is it's going 1.16, oops, that's a 6. How about we fix that? 1.16 to the right, and we have 2.01 to the up. And then our resultant is going to be here. And that matches our drawing here. So we need to find this value and that angle, because vectors have magnitude, this is our magnitude, and direction. The angle is our direction. Okay, so I'm going to redraw this on another page. So we have 1.16 and 2.01. We're looking for this and our angle. Okay, we have a right triangle because x and y are perpendicular to each other. Okay, so what do we use to find the resultant or the hypotenuse? Isn't that a hypotenuse of a right triangle? Yes, you're right. Pythagorean theorem. So we're going to go 1.16 squared plus 2.01 squared, and that equals our resultant squared. And so our resultant comes out to 2.32. At least that makes sense because it needs to be bigger than either of the sides. Okay, So 2.32 is our resultant. And then to get the angle, okay, so here's our angle, SOHCAHTOA. This one's the opposite. This one's the adjacent. Oops, that's, I can spell. The adjacent. Okay, so we're going to take SOHCAHTOA. So we're going to take the tangent of the angle, and that's going to equal the opposite, 2.01, divided by the adjacent, 1.16. And so we get the tangent of the angle equals a number bigger than 1. So our angle is actually bigger than 45 degrees. 2.01 divided by 1.16 is 1.73. Okay, so we need to get theta all by itself. So to undo a tangent, you take the inverse tangent of both sides. So theta equals the inverse tangent of 1.73. So theta is, okay, inverse tangent equals 59.97. So we're just going to call that 60 degrees. Okay, if your numbers didn't match up with mine, check. First of all, are you in degree mode? Are you closing your parentheses when you add up things? And then here's a thing that happens with your calculator. This is a vectors together. We ended up with a final vector of 2.32, and then its units are going to match whatever these units were. So if it was meters per second, this is going to be meters per second. If it was meters, this is going to be meters. If it was kilometers, this is going to be kilometers. So it's 2.32 units, whatever those are, at 60 degrees up and to the right. And we know it's up and to the right because both of our, see, it's going up and it's going to the right. Okay? So that's our final answer right there. 2.32 units at 60 degrees up and to the right. All right, you're going to have a chance to practice this and with help, so good luck with that. Bye. Horrible thing. So let's say our two vectors were negative and we'd had like negative 1.12 and a positive, whatever the other number was, 2.01 squared. All right. If you put this in your calculator, it will go the negative of 1.12 squared. Okay, it won't square the negative. Personally, I don't put the negative in the calculator because it just makes, I mean, what do you get when you square a negative number? Don't you get a positive number? And so it doesn't make a difference. But if you're going to put it in your calculator, you need to put the negative in the parentheses. Okay, you need to make sure it goes actually in the parentheses. So if this number, c squared, if when you find c, it's smaller than either of those, you probably did this thing and you forgot to put it in the parentheses like that. So look for those common errors. It doesn't mean you did it wrong. So a lot of the mistakes here are not that you didn't know how to do it. A lot of them are just calculator errors. So the first step is to go back through your calculations and make sure you got the right numbers. Did you push the right buttons? All right? So when we added all our